Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 2 of Observability Zero to Hero series. In the first episode, we learned about the fundamentals of observability. In this video, we will learn about metrics as well as monitoring. So we will start with the first pillar of observability, that is metrics. Let me explain in detail what are the things that we are going to learn in the video. We will start with understanding what is metrics using a real life example. Then we will understand the difference between metrics and monitoring. A lot of people fail to understand this difference, but I'm sure after watching this video, it will be very clear. Then we will learn what are some of the example metrics, that is commonly used metrics by DevOps engineers or SRE engineers, which they deal with on day-to-day basis. Then we will head towards learning Prometheus. So we will learn what is Prometheus. We will learn about the architecture of Prometheus, because Prometheus is the most popularly used monitoring tool in the world of Kubernetes. So we will learn what are the different components of Prometheus, such as the push gateway, retrieval, time series database, alert manager. We will try to understand what all these components are. Then we will learn how to install Prometheus on a EKS cluster. Finally, we will learn how to configure Prometheus as a data source in Grafana. That is how to install Grafana, how to set it up and integrate it with Prometheus for visualization. So we will cover all of these things in today's video. If you want to refer the notes, like after watching the video, if you want to do a very quick revision, you don't have to go anywhere. Just go to this repository, Observability Zero to Hero, go to the Day-2 folder, and in the Day-2 folder, you will find a README file. And this will explain everything that I have covered in the video, along with diagrams, architecture, and you can also find the commands that I'm using in the video. So it will be a very quick revision thing. So make sure after watching the video, spend 15 to 20 minutes on this. Okay, now we are clear about what we are going to learn. So let's start with what is metrics. Let's take a real life example. So assume there is a patient. So a patient is admitted in the hospital. Assume the case. So obviously a nurse would be assigned to the patient, and nurse would attend the patient periodically. That means every 15 minutes or 30 minutes or even once in an hour, depending upon the criticality of the patient, nurse would attend the patient and collect some key information or data points about the health of the patient, such as the blood pressure or the heartbeat of the patient and anything that is important. So the nurse would keep a note of this information. That is, at 10 a.m. in the morning, if you assume nurse attends the patient once in 15 minutes, so 10 a.m. in the morning, the heartbeat is 76. Then at 10:15 a.m. in the morning, heartbeat is 81. Throughout the day, nurse would collect this information. Similarly, nurse would collect same information for the blood pressure and anything else, right? So throughout the day, nurse would collect this information. Why? Because at the end of the day, if doctor wants to understand the health of the patient, is the patient's health stable? Is the patient doing good? How can the doctor understand? By looking at this information. So doctor looks at the periodic information of the heartbeat, periodic information of the blood pressure, and if everything looks normal, that is in the 15 minutes interval throughout the day, if everything looks normal, then doctor would decide that the patient is okay, in a good condition. Let's say there is a abnormality at one particular time of the day. Maybe after medication, it is noticed that the patient's heartbeat goes down, or during the sleep, the patient's heartbeat is just above the average good condition. Then doctor would decide that, okay, patient needs more time at the hospital, or patient needs to be critically observed. Assume if doctor does not have this information, how would doctor understand the health of the patient? It's not possible. So these things, like this is a metric and this is another metric. So these things are called as metrics. So metrics are nothing but periodical information or historical data. So if you want to get a definition, so I would say historical data of the events to understand the health of the system. That is nothing but metrics. So using metrics, you can understand if a system is in the good condition or not in the good condition. But one problem with metrics is that it is complete raw information. That is, all this information is written on maybe a notepad, or this is written in a Excel sheet. So it is quite raw information, which is not easy to read. And also, because this is too much numerical information, at 10:15, the heartbeat is 81, at 10:30, heartbeat is 62. So too much of numerical information, you might also miss some things. So what is the right way to deal with metrics is that feed the metrics to a monitoring system. Even if you look at the hospital, you can see that the heartbeat of the patient is continuously collected either by the nurse or using a machine, right? Because if the heartbeat has to be collected every 30 seconds, nurse cannot do it. So you need a machine that is connected to the patient, which records these metrics. So what actually happens is this metrics is fed to the monitoring system, or the monitoring system reads the metrics and represents the metrics in a graphical format or in a dashboard that is easy for anyone to read. Let's say I give you lot of data in an Excel sheet versus a graph or versus a pie chart. What is easy to read? Obviously, the dashboard, the graphs or the pie charts are very easy to read. So monitoring system collects the metrics or scrapes the metrics, which is like pulls the metrics and represents the metrics in a dashboard format. It can be any kind of the dashboard, so that it is easy to understand. If there is a spike, you can clearly see in the dashboard. Maybe in the raw data, in the notepad or in the Excel sheet, you might miss that information. But if you are seeing a graph, you can clearly see the spike in the graph So the dashboards are much better. Not only that, in the monitoring system, what you can also do is you can set an alert. That is, you can set an alert saying if the heartbeat of the patient goes above 90, send a notification or send a text message to the nurse or send a WhatsApp message to the nurse. And if the heartbeat goes over 110, send a WhatsApp message to the doctor that you need to immediately attend the patient, right? So a monitoring system is basically getting the information from the metrics or scraping the information, pulling the information from the metrics and representing that information in a well readable format using the dashboards. And it is also capable of firing the alerts when something is wrong, right? Firing alerts is basically notifying. The heartbeat of the patient is down. You need to immediately take an action. So it can read the metrics, it can represent the metrics in the dashboard format, and it can also send an alert or fire an alert when something is wrong. That is a monitoring system. So metrics is a subpart of monitoring, or monitoring depends on the metrics, but it is much more than that. Now, Abhishek, can you explain this scenario in the world of IT? So this is very clear. I got understanding of what is metrics and what is monitoring. So if we try to understand this in the world of IT now, I hope this will be much easier now. So assume there is a application, just like a patient, you have a application that is deployed in the AWS environment on a Kubernetes cluster, let's say. So the nodes of the Kubernetes cluster are AWS virtual machines, and there is also AWS networking like virtual private cloud. To understand the state of this entire system, not only of your application, about the Kubernetes cluster, about the AWS infrastructure, even if any of these things is not right, your application will not be stable, or your application cannot be up and running 24/7. There will be some bad user experience. So to monitor the system or to understand the health of the system, what you would need is metrics. Just like we understood the metrics of the patient, similarly, there would be metrics for the complete system, such as the CPU of virtual machines on AWS, which are nothing but the Kubernetes nodes. So what is the historical information of the CPU of the nodes? At 10 a.m., what is the CPU utilization of the node? At 12 p.m., what is the CPU utilization of the node? So that you can understand whenever there is an abnormality. Maybe in the evening, your application is receiving a lot of requests and CPU went up, something like that. Similarly, you can also collect another metric such as the memory of your AWS virtual machine. This is some examples of infrastructure. You can also gather metrics for the Kubernetes cluster, something like the pod status. How many times the pod went into crash loop back off throughout a day, and at what time the pod went into crash loop back off, or the deployment status. Or if you are using, let's say, a HPA, you can also see the replicas of deployment. That is, throughout the day, at what point of time you have 10 replicas, 2 replicas, things like that. And you can also collect some application specific metrics. For example, the HTTP requests received by your application, total number of HTTP requests received in a day, or at 5 a.m. in the morning to 6 a.m. in the morning, is your application even receiving traffic? You can understand that using HTTP requests. Or it can be too much application specific, something like maybe if you're using a e-commerce application or a tech platform, where you want to get the metrics like how many users have signed up in the last 30 days and at what time the users are usually signing up. If there is a new account creation, at what time of the day is it happening? At what time of the day are the users deactivating from the platform? Or it can be how much time users are spending on the platform, right? Anything that is user specific, you can also collect such metrics. So all these metrics, depending upon your company, you can collect hundreds of metrics, or you can collect just 10 metrics, or you can collect some 50 metrics. There is no requirement, or there is no recommendation as well. It depends how many number of metrics that you want to collect to understand the health or the status of your system. Okay, now Abhishek, we have collected this metrics. How about monitoring? Exactly like the same example. These metrics are either fed to the monitoring system, or monitoring system will automatically pull these metrics. It can be the push mechanism, or it can be the pull mechanism. We will use a common word called as scraping, which can be understood as pull. Remember this word, I might be using a lot of times. So either the monitoring system will get this information, somebody will push this information to the monitoring system, or monitoring system will scrape this metrics, pull the metrics, and it will represent this information in a visualization format. That is the graph format, so that you can select this graph time period as 30 days. Best example is your stock market, right? If you go and select a particular stock, you can select last 10 days, last 1 month, last 1 year. How are you getting that graphs? It is from the metrics that is collected, that on one particular day, at one particular time, this is the price of the stock, right? So that information, the historical information, is your metrics. And who is creating that graph? Your monitoring system. It is taking the information and representing the information in a dashboard format. And in this monitoring system, you can also fire alerts. If the CPU utilization of a particular node goes above 80%, fire an alert. If the disk utilization of a virtual machine on AWS, which is used as a node in the Kubernetes, if the disk utilization goes above 75%, send a Slack message in the DevOps engineering team group, or in the SRE engineering Slack team group. Similarly, you can do it for any kind of thing. Let's say a lot of users are deactivating the platform. Even for that, you can create a matrix. Or if users are seeing a latency, that is, if the HTTP request processing is taking, let's say, usually if it takes 5 seconds, you have noticed it is taking 10 seconds. And if this 10 seconds is seen 30 times in a day, fire an alert to the Gmail or Slack of development team. So you can configure these kind of alerts. So I hope you understood what are the metrics. So these are some of the metrics that you collect, or the system collects. It can be a application, it can be a plugin, anything that collects this metrics, and monitoring system pulls these metrics, represents in the dashboard format, and in the monitoring system, DevOps engineers or SRE engineers creates this alerts rules. So when to fire the alert, where to file the alert. So this is about monitoring. So I hope you understood the difference between metrics and monitoring now. Monitoring is a superset where it has metrics, it has dashboard as well as alerts. Okay, now Abhishek, where did Prometheus come into picture now? So Prometheus is the top or very popular open source monitoring platform in the world of Kubernetes. So Prometheus can scrape the metrics, or Prometheus can also be sent the metrics. Somebody can also send metrics to Prometheus. But popularly, what this Prometheus does, okay, so it will pull the metrics from various sources. I'm going to cover this thing as well, how Prometheus collects huge amount of metrics. There are things like exporters. There is something called as kube state metrics, and there is something called as metrics endpoint of the application, which I'm going to cover in next 5 to 10 minutes. But Prometheus pulls various metrics from your AWS or your Kubernetes cluster, represents them in the dashboard format, and in the Prometheus, you have a component called alert manager, and you can configure this alert manager to fire the alerts. Abhishek, I want to understand detailed architecture of Prometheus. No problem. If you go to the documentation, Day-2 folder, in the README file, just scroll down and zoom out. Let me zoom out. So you can see here, this is the complete architecture of Prometheus, where this is the Prometheus server, the component that you are installing. And in the Prometheus server, there is a sub component, or there is a part called as retrieval. The arrows are pointing towards the wrong direction. So actually it is pull metrics. So retrieval pulls the information from exporters. Today, if you are not understanding anything like exporters or push gateway, don't worry. We will play with them day 3, day 4 as well. But Prometheus will pull the information from exporter or the push gateway, where any application can forward the metrics to the push gateway. Prometheus will pull that information, and Prometheus stores that information in a time series database. For simplicity, if you are complete beginner, ignore this push gateway for now and understand Prometheus. The retrieval in the Prometheus pulls the metrics from the exporters, and it will store that information in the time series database. What is a time series database? Basically, in the metrics, time is very important, right? So whenever you are storing time along with the key value pairs, right? So at this particular time, that is 10 a.m. in the morning at 6 seconds, the heartbeat of the patient is 81 or 71, right? So along with the time, you are also storing some key value pairs. So this is called as time series database. I explained this for simplicity. We will play with the metrics time series database. Don't worry. So, okay, the information is stored in the time series database. And if you want to get that information from Prometheus, let's say you want to get the information for last 20 minutes, last 30 minutes. Okay, so you can query the HTTP server of Prometheus. Prometheus supports something called as PromQL, Prometheus query language, right? To get information from Prometheus, that I want the information from last 30 minutes. So you can write a PromQL query. We will write some PromQL queries. We will learn how to write them. So when you pass that PromQL query to the Prometheus HTTP server using the user interface, right? Prometheus will give you that data back, which is taken care by the HTTP server. When we use the user interface, some of these things will become clear to you. And like I told you, you can also use the alert manager to fire some alerts. Okay, Abhishek, it can read information from exporters. What if I have some specific metrics that are sent by my application, right? In the Kubernetes cluster, I can have multiple applications. How can I tell Prometheus that, okay, out of 100 applications that are in my Kubernetes cluster, only read metrics from 50 applications, or only read metrics from 30 applications? So there is a concept in Prometheus which is called as service discovery. Using this service discovery, you can tell Prometheus that, okay, these are your targets, right? So as we keep using Prometheus, you will understand more about the Prometheus architecture. One thing to note is Grafana. So Grafana has strong visualization, like the strong dashboards. When this Prometheus system is integrated with Grafana, you can see very rich dashboards. You can see different types of graphs. So usually Prometheus is integrated with Grafana, and both of them together are used as monitoring stack. Like I told you, metrics, dashboard, and alerts, right? Grafana is very rich in dashboards. So it is combined with Prometheus very often so that they become very strong monitoring stack. Let's try to install Prometheus, right? Before we learn anything more about Prometheus, like before I explain what is exporters, what is this metrics endpoint, let's first install Prometheus, right? Because we have been learning a lot of theory. Before we cover some more theory part, let's install it. So you need a Kubernetes cluster. You can also do it on your Minikube or on your micro K8s kind, whatever you are using. I am using a EKS cluster, which is a production like environment. And throughout this, I would be using EKS only because I wanted to give you a feel of real-time environment. So let me log into my AWS. Perfect. So I have signed into my AWS account, and let me go to the EK service. You can see I have a Kubernetes cluster. If you also want to create a similar Kubernetes cluster, make sure you delete it after using. But if you go down, you can find the commands how to create EKS cluster. First, create a cluster, associate the OIDC provider with it, and then associate a node group. Why do you need OIDC provider? Maybe for today's video, it is not required. But when your Prometheus want to communicate, or the Prometheus application within the Kubernetes cluster wants to communicate with any other AWS services, this OIDC provider is important. It connects the Kubernetes service account with the IAM roles or the IAM policies in your AWS account. Okay, so we have done that. Now let's head towards installing Prometheus. So I will take my terminal. I hope I have Helm installed on my terminal. If not, I would do it. So let's fire this command. Okay, I already have Helm. If you don't have Helm, please install Helm and run these commands, which are used to add the Helm repositories for Prometheus. Now that we have, let's create a namespace for monitoring where we are going to install Prometheus and Grafana. Okay. Clone this repository because you have all the files in the repository. So what I'm going to do is git clone the observability 0 to hero and go to the repository in your local, then switch to the Day-2 folder. So in the Day-2 folder, once you go there, run the Helm command using this custom file that I have passed. Okay, Abhishek, why are you passing this custom file? So if you look at this file, which I'm passing to the Helm command, here I'm just asking it to enable the alert manager, which is for firing the alerts in our future videos. Of course, we will not fire any alert in this class, but I'm explaining Prometheus that, okay, along with your default components, if you see the default components of Prometheus, it comes with Prometheus server, retrieval, time series database, and HTTP server. But I am also installing the alert manager, which is a custom part. Perfect. So let's go back. Let's see if the alert manager and okay, I did not press on enter. So the Helm installation is under process. Okay, looks like Prometheus is installed. Let's run these commands to see. So in the namespace called monitoring, I'm just looking out for pods. So I can see the kube state metrics is installed. I will tell what is kube state metrics and node exporter as I promised. And the Prometheus is also installed. Okay. So we have the Prometheus related things running. Next, we will try to access the Prometheus UI. After that, we will understand what is node exporter and kube state metrics. So let's use the port forwarding mechanism. Perfect. So the port is forwarded. Let's also forward the port of Grafana. If you're wondering how Prometheus is already installed and Grafana is also installed, in this particular command where we are using this Helm chart, right? This is also installing Prometheus as well as Grafana. Okay, I have used the kubectl port forward command. Otherwise, I have to use ingress. And let me take another tab, new tab with the same profile. And here I will expose Grafana. I will do the port forwarding for Grafana. And let me take another tab and do that for alert manager as well, so that we can check all of these things at once. Everything is installed or not. Okay, so we have forwarded all the ports. So go back and let's try to access one of these. Let's start with Prometheus. So because I have done port forwarding, take your browser, paste it. You will see the Prometheus user interface. Again, I am not using ingress. What I am doing is I am using the kubectl port forward command. It is a port forwarding mechanism. We will use ingress in the later videos, but today it's the first class. So instead of creating 3 ingresses and ingress controller confusing you, I am using kubectl port forward. Okay, so you have Prometheus. Similarly, let's try to access Grafana as well. So copy this command, take your browser and paste it. So for Grafana, it will ask you for the password. If you go to the document, I think we have the password here. Once Grafana is, yeah, the password is prom operator. Okay, in the Grafana, provide the username. So let's provide the username as admin and password as prom hyphen operator. Okay, so the login is successful. So we can see the Grafana dashboard as well. Perfect. Finally, let's also try to assign the, sorry, access the alert manager. So again, take a browser and 9093. So we have the alert manager as well. So we have installed all of them on the Kubernetes cluster. This is what you would exactly do for installing Prometheus, Grafana, and Alert Manager in your organization as well on the EKS cluster. You would use the same Helm chart, same configuration. Only thing is that instead of using kubectl port forward, the command that we have used here, the port forward, you would use an ingress resource and ingress controller. We will also do that in the next videos. But for now, we have covered the installation of Prometheus, Grafana, and Alert Manager. If you go to Grafana, you can see here that there is a dashboard section where you can see some default dashboards already. We will cover that in tomorrow's video. What are the dashboards? How to use these dashboards? How to customize the dashboards? All that will be covered in the next class. Then you can also see the alerting rule configuration that I have mentioned. And you can go to the connection section, add a new connection, and here search for Prometheus. PRO, right? So you can see the Prometheus data source. And what you need to do is just provide your Prometheus URL, right? After providing that, this Grafana instance gets connected to the Prometheus. Of course, right now, we don't have a lot of metrics. So we will see the connection in the next class. How is it connected and how you can see the dashboards in Grafana. Okay, now let's move towards the final part and understand, okay, Abhishek, how does Prometheus scrape a lot of metrics? Because I told in the example that when you have a application, you have lot of things related to the application. You have the AWS infrastructure that needs to be monitored. You have the Kubernetes cluster that needs to be monitored, and also the application that needs to be monitored. So how one Prometheus can take care of all of those things? So you need to understand there is a concept in the Prometheus called as exporters. So these exporters are nothing but add-ons or plugins you can understand. So along with the Prometheus installation, if you install these exporters, like each exporter can take care of one thing. For example, you have a node exporter in Prometheus, which is an add-on or a plugin. So this node exporter in the installation that we have done, we have also covered that. So if you just search for kubectl get pods -n monitoring, you can see we have the node exporter already installed, right? These ones. So it is a very common thing. That's why the default Helm chart installs node exporter. And what this node exporter can do is it can get the node related metrics. So it can continuously pull the node related metrics. What this node exporter does, it goes to each node of your Kubernetes cluster or each virtual machine of your Kubernetes cluster, and it pulls information like from the proc files, it can get the CPU utilization, or from the system, it can get the CPU utilization. So Every minute, it will pull this information from the nodes of your AWS or Kubernetes cluster, and it stores these metrics. So the node exporter can give you the CPU related metrics, the memory related metrics, the disk utilization related metrics. It will store all of these things, and Prometheus will pull these metrics, right? So now Prometheus got the metrics related to your nodes. Similarly, there is another exporter called as kube state metrics. So this is another exporter, kube state metrics. And what this kube state metrics does is it will get all the information from your Kubernetes API server, right? So from the Kubernetes API server, it can get all the information such as the pod status, the deployment status, how many times your pod crashed, how many Kubernetes events your pod has omitted, everything that you can get from the Kube API server. This kube state metrics, which is another exporter, add-on, or plugin, will collect all this information as metrics, and Prometheus will scrape the metrics or pull the metrics from kube state metrics. Again, kube state metrics is also installed in the default installation. If you see here, kube state metrics is also available. So these are the two primary things. The Prometheus installation relies on the node exporter for exporting the information or scraping the information from the nodes. Along with that, it relies on kube state metrics to get any information of the resources on the Kubernetes cluster, such as pods, config maps, secrets, anything. It scrapes this information from kube state metrics. How kube state metrics gets this information? It will always talk to the API server. How node exporter gets this information? It will communicate with the virtual machines or the nodes and reads the system files of the nodes, where CPU information is recorded, where memory information is recorded. Okay, we got the infrastructure level metrics, we got the Kubernetes level metrics. How about application level metrics? Like I was giving example about HTTP server, sorry, HTTP requests, or I was giving example about user level signups, user level deactivation metrics, or how many times a user performed a specific activity on your application. To get that, the developers of the application should write something called as metrics server. So just like how you have /login page, /logout page, developers should also write the metrics API, which is /metrics endpoint, and Prometheus using the service discovery mechanism. So you can tell Prometheus that, okay, these are the 50 applications from where you need to scrape the /metrics endpoint. So depending upon the applications that you provide, Prometheus can scrape the /metrics endpoint of your payments application, catalogs application, any applications that you have. So these are three primary things that is used by every organization. Apart from that, there are multiple other exporters for Prometheus. It has a database exporter and multiple other, but these are the three primary things. Node exporter for your infrastructure, the node infrastructure, kube state metrics for your Kubernetes related information, and /metrics endpoint for your application level metrics. Now the final question, Abhishek, are there any competitors to Prometheus? Yes, there are so many competitors. Like there is Nagios, which is also open source, a competitor of Prometheus. You have InfluxDB. There is something called as Graphite. So there are so many competitors, open source and also closed source. But the reason why Prometheus is very, very strong, or why it is very commonly used, is it is a CNCF project. In fact, it is the second CNCF project after Kubernetes. So it has a very strong community. And lot of closed source tools or lot of companies who are building observability tools are using Prometheus as monitoring instead of writing their own monitoring servers or creating monitoring from scratch, right? So this is the information for today's video. Make sure you go through the notes, and also you can take a look at the Prometheus official documentation if you need more information. What we will do in the next class, we will learn more about PromQL. We will learn how to get the metrics information from kube state metrics, from the node exporter, and play with those metrics on the Grafana dashboard. So we will see the graphs, representation, and everything. Thank you so much for watching today's video. I hope it is informative. See you all. Take care. Bye-bye.